design or not. When you start talking about localization and things like that, it might not be so good, actually. But it's really simple code, and we're trying to do something simple, so there's a few lines of code for you to try and interpret as possible. Now we need operation buttons: times, divide, plus, minus, square root, equals. So I could copy and paste a digit button, but that would be bad. And that's because I would end up with a button that was sending both digit pressed and operation pressed. Okay? You can definitely have buttons that send two messages, and you don't want that. That would be very confusing to our controller. So I'm going to drag out a new one, set it here. I'm going to make it 64 wide as well. And this one, I'm holding down Control again, dragging to my controller, letting go. This time, operation pressed. Okay? So now this button is going to do that. I could put the times on there, let's say. Again, I can copy and paste, 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 paste. Oops. Over here, paste. I'm leaving a space down here for square root intentionally because your homework is going to put a particular kind of button right there, I think. So I'm leaving space for you. Oops. You can undo, obviously. I just undid there because I misclicked. So let's do square root right there. Let's do divide. Let's do plus. Let's do minus. And we're going to do equals. Okay, so that's all our buttons. They're all laid out. They're all set to what I want them to look like and what they have on them. They're all set to send messages to my controller. So I'm done with those. The last thing I have to do is my display. Okay, so that is a label. Label, which is the class UI label, which you can see down here actually. Whenever you click on something in the library, it's going to tell you the class of it. So here's the UI label. Label is static text, okay? Output only text. You can't edit it. It's not editable. There's another class down here, text field, for input text. Maybe I'll give you a little idea of how big this library is. We got date pickers, advertising banner view, map view, a web view showing images, tables, even other view controllers here, navigation controllers, navbar controllers. And this is sliders, but switch. There's a very extensive library of things to choose from here. But what we want is label, so I'm going to pick that up, drag it up here. We can try and resize it to what we want. I don't really want it to say label when our interface starts, so I'll change it to say 0. Now, this is really not what I want either. First of all, calculators, the numbers come from the right? They grow out from the right. So I need this thing right aligned. Also, it's too small. I want it to be pretty big, the numbers to be big. So let's use the inspector here so we can see how that works. So I have the label selected, right? There's a button selected. Here's the label selected. And you look over here and you can see that in the inspector, the leftmost tab, it's showing all the attributes of a label. Notice it's also inheriting all the attributes of a generic view because a label inherits from view. So the inspector is nice in that it works in an object-oriented way. As things are subclass, the inspector picks up all the attribute setting. So here I want it to be right aligned, and I also want to change the font. So this brings up a standard font chooser here. I'm going to go pretty big, let's say 36. Yeah, looks good. Maybe I'll do a little more sizing here using the blue lines rather, something like that. Okay, so that looks good. I'm happy with that. Now all I need to do is set that last outlet, the connection from our controller to the thing in the view we want to talk to. And I just do that by Control. I'm holding down Control and dragging up, okay, to the display. Let go. And here's the, as promised, little black window. I'm going to hook this one up to display. All right. So now I have an instance variable called display. You'll remember every time I want to send a message to my display, I can just send a message to that object. It's going to get sent to this object. Does that make sense? Okay, great. So that's it. We're done. Our view is completely finished here and completely wired up to our controller. So we can go back to Xcode. We could run our application right now. So I'm just going to hit this build and run. And there it is. Now, what's going to happen if I click on one of these? Yeah, it's going to crash because we'll be sending digit pressed to an object that doesn't implement it. Okay, it's in its header file, but it has no implementation. So we'll try it. Click, crashed. Okay, our application crashed. So that's no good. The simulator didn't crash, our application crashed. All right, so what next? The next thing I want to do actually is take a break from our view controller. We'll go back and implement that. Let's implement our brain first, because obviously our controller is going to want to use our brain to do the calculations. So let's implement our brain. Okay, let's do the implementation of our calculator brain, which is this guy right here. So, what instance variables do we need from our calculator brain? First and foremost, we need our operand. It's the same as I said on the slides. That's really all we need for now. I might need another instance variable in a minute, but for now, that's fundamentally all I need. And then the methods that I told you we were going to need are setting the operand and also performing the operation. Okay. Now, notice that the operation is specified as a string. Now, we're going to be really tricky here and just use the string that's on the buttons, which, again, in a localized world, I'm not sure SQRT means square root in, German. Probably some really, really long named thing. So we would probably want to use some other mechanism, but we'll go short circuit here. And really, I believe that the way we're doing it is a violation of MVC. Even though the view is not sending any message directly to the model, the view and the model are making an assumption that, about what these strings mean that's shared, that's a little questionable. But again, for expediency of doing this demo, we're going to have the strings mean the same thing. The string on the button means the same thing as the operation we want to perform here. Now, I'm going to copy and paste. Okay, I'm selecting my two methods and copying them, and then I'm going to go over to Calculator Brain and paste them. Okay, but I'm going to get rid of these semicolons and put my curly braces in instead. Okay, for my implementation here. Yeah, question?
I was wondering why you pass a pointer to a string rather than the active string.
As I said, all the objects in Objective-C are allocated on the heap. So you can only have pointers to them. Okay, it is only possible to have pointers to them. You can't allocate them. I couldn't say inside of a method ns string s. I'd have to say ns string star s and then allocate it. And we'll talk about next week how you allocate objects out of the heap. We're kind of waving our hands on that today. Actually, I'm going to show you today, but I'm not going to spend much time on it. But anyway, so that's why we always have ns string star, ns array star. It's always a star. All right, so that is our kind of basic implementation here. How are we going to do our calculator brain? Set operand is easy. That's just operand equals an operand. So here I'm just taking my operand, which is a double instance variable, and I'm setting it to the argument that was passed in there. Okay, that should be pretty self-explanatory. Next, let's do perform operation. I'm going to do square root because it's a really easy one to implement. Okay, so I'm going to say if. Now I'm going to send a message here, square bracket, operation. So I'm going to send a message to the operation string that was sent in. And I'm going to ask it, are you equal to the string square root? Okay? So @ quote square root creates it creates a string object, an ns string star. The compiler creates it for you. It's kind of it points to a constant data somewhere, but you don't know that. But it's just like any other string. Okay, it is no different than any other string. It looks funny, I know, to write it that way, but don't forget that little @ sign at the beginning. If you don't put that @ sign there, it's a const char star. Okay, like a C, const char star. And if you are passing that around as an NS string object, that's not going to work. Okay, because it's not an object. It's literally a const char star. So when you start programming on iOS, you'll forget that @ sign quite a bit. Okay, but you got to remember to put the @ sign in when what you want is a literal constant string. So there's square root. So if it is equal, what are we going to do? Well, I'm just going to take my operand and make it equal to square root, C library function of operand, my current operand. So my calculator brain has an instance variable which is its current operand, and all I'm going to do if the operation I'm asked to perform is square root is just take that operand, take the square root of it, and make that my new operand. And then I told you that I was going to return my current internal operand from this method just for convenience of the caller. Okay? If I didn't do this, I'd have to have another method called basically get operand that the caller would have to then call to get the operand. This way, it's a little easier for them. So that's single operation, real easy peasy, and you can imagine adding all kinds of single operations here. Let's talk about multiple argument operations like times, okay, and plus. Now, I could have done a reverse Polish notation calculator here, and this would have been a lot easier because I just have this stack of numbers, and I just start pulling them off 2 at a time as I was doing times and plus. Instead, we have this normal calculator where you say 3 times 5 equals, or you might even say 3 times 5 plus 6 equals. And so when is the operation actually happening there? Because when I say 3 times 5, the operation doesn't really happen until I press another thing, like equals or plus or something else. So we kind of have to have our operation, that times in 3 times 5, waiting around until another operation gets performed. Then we can go back and perform it. So it's, you see what's going on there? Kind of goofy, but not that easy, not that difficult to code up, but just maybe a little difficult to understand what's going on. But anyway, so I'm going to say else, meaning if it's not the single operation square root, and if I had other ifs, I could if then else, if then else. This all looks like C, hopefully, to you or similar to it. I'm going to say self. I'm going to send a message to myself, perform waiting operation. Now, I'm intentionally putting this in another method because I wanted to show you A, how to make a private method, and B, how to send a message to yourself. Okay, now hopefully this line of code is pretty straightforward. It's square brackets on both sides, so I'm sending a message. The object I'm sending a message to is myself. That should make sense if you're no object-oriented programming. And the method I'm sending is perform waiting operation. It has no arguments. Okay, that method has no arguments. So it's going to have to use some internal instance variables to do what it does. Now, so this is going to perform any operation that's kind of waiting to happen, like the 3 times 5, the times that's waiting for its next operand to get entered. But we also here have to record the current operation because it starts being the waiting operation. So I'm going to say waiting operation, which is going to be a new instance variable, equals operation. And I have to keep track of the operand. Waiting operand equals operand. Okay? So I'm going to have 2 instance variables I'm going to add, waiting operation, waiting operand. They're just going to keep, this is 3 times 5 equals. This is going to keep track of the 3 and the times. Okay? So that when the person goes 5 equals and the equals happens, or they go 5 plus and the plus happens, we can go back and use that waiting 3 and waiting times, multiply it times the current operand, which would be 5, get the result. Okay? So let's add those instance variables back here. So waiting operation is a string, operation, and waiting operand is a double. Okay? So that's that. So all we have to do now is implement our perform waiting operation private method. One thing to notice about the private methods is they need to be declared in your implementation file before you use them. Okay? If you don't, you'll get warnings from the compiler because it, typical order of compilation issue. So here I'm going to say void perform waiting operation. Okay, it's void, doesn't return anything. What does this method look like? This one's also very simple. I'm going to throw a little curveball at you here just so you can really believe me about strings. I'm going to say if plus is equal to the waiting operation, then I'm going to say my operand equals my waiting operand plus my operand. Okay, notice there I've taken that string literal, @+, I sent it a message. And it's in a string just as much as waiting operation is. I could have put it the other way around. I could have sent waiting operation the message, right? Asked it if it is equal to @+. But I can also send a message to @+ saying, are you equal to waiting operation? Okay, I just want you to make sure you understand that @ strings are real objects. Okay, they're created for you, but they're real. All right, so let's do our other operations here. Minus is equal to waiting operation. I might do some copy and paste here if you don't mind. So that would be operand equals waiting operand minus operand. You got to be a little careful of the order here, but I believe this is the right order. We'll do some copy and paste here for the last 2. Copy, paste, paste, paste. Let's do times is times. Some of you are saying, ooh, divide. What's going to happen with divide? Because if I go like this, what happens if operand is 0?